All right, so now we have seen the central limit theorem. It's a pretty big deal, and that was this page right here. So now we're going to use it to figure out some things. So for example, we're going to determine the mean of the sample means, mu sub x bar, and sigma sub x bar, oops, sorry about that, from the given parameters of the population and sample size. So let's begin with the first one. You know that for the population, mu equals 100, sigma equals 30, n equals 40, but you don't know anything about the shape of the original distribution of x. Well, that's okay. When they ask us to determine these things, what they really want to know is what's shape, what's the center, what's the spread. Okay. Now, shape, we really want it to be normal. So is it? And the answer is yes, it is, because even though we know nothing about the original distribution, n equals 40 is greater than 30. So the sampling distribution is normal. Next, the center. Okay, well, the center is, oops, disappeared. Come here. The center is the mean of the x bars. Which is equal to mu, according to the central limit theorem, which is equal to 100. Done. Now what about the spread? The spread is, oopsie, sigma, which is, according to the central limit theorem, sigma divided by the square root of n, which is 30, oopsie, 30 divided by the square root of 40. Let me pull up Excel for a second. Make this bigger so you can see it. Equals 30 divided by SQRT 40. 4.74 roughly. 4.734, I'll put it in there. Squiggly equals 4.7, oopsie, I pressed pi accidentally, 4.734. There we go. That's all there is to that. Now, what about letter B? Here, nothing is known about the shape of the distribution again, but n is only 20. So the shape cannot be determined because n is equal to 20 is less than 30, and the original distribution is not known to be normal. Done. Okay, what about the next one down here? Oopsie. Okay, so we know the shape is normal this time, but not for the same reason. N is only 20, so it's not because n equals 40. It's known because the original distribution of data for the population is known to be normal. All right, what about the center? Well, the center is going to be the same as it was before. It's the mean of x bars, which is equal to mu, which is equal to 100. Hasn't changed. Sigma sub x bar is going to change, though, because it's going to be 30 divided by the square root of 20, which is, oops, I typed that wrong before. Well, that's okay. I'll go back and fix it. So this time it's 20, 6.708. 6.708. And let me fix this one. This was 4.743. My fault. There we go. All right, so now we know how to determine the population parameters, I mean the sampling distribution parameters based on the population stuff. All right, now what does this mean for probabilities? Well, it means a lot. So let me see if I can find you a picture. Okay, I drew this on my program here. And I'm leaving it this big because I really want you to be able to see it because it's really interesting. This little fat curve right here, that is when n is equal to 1, right? The population curve. And up here, the big tall one, that's when we're dealing with our sample size. And notice how big a difference that is. All right, let's keep that in mind. I'm going to talk about it through the whole next video, I bet. See you then.